So a scatter plot, it's a graph like we have here. This is a scatter plot. The points are scattered on the graph, but it can show a relationship between two variables. Okay? And the points in a scatter plot often show a pattern or a, what's another word for a pattern? Trend. Excellent. Okay? And we talked about this. We can look at positive relationships, negative relationships. The trend can be increasing or decreasing. So from that, you're able to describe the relationship between the two variables. So we're going to look at an example here. Julie gathered information about her age and her height. So one of them is the independent variable and one of them is the dependent variable. Do you think your age depends on your height or your height depends on how old you are? Your height depends on your age. So this is dependent and age would be independent. And we talked about this before. Independent always goes on which axis? The X or the Y? X. So we'll put that there. It's always on the X axis. The dependent variable is always on the Y axis. So if this is our dependent variable, can we label the graph? It hasn't been labeled. We have age is our independent. And what am I going to write for the Y axis? What are we looking at, a relationship between age and Mohammed? Height. And it's her height in centimeters. Okay, so we've labeled the vertical axis. And now I want you to think about this for a second. I want you to describe the trend. So we can say that as her age is increasing, as she's getting older, right? As she gets older, as Julie gets older, so as her age increases, you can use that language as well, she gets taller. So as age increases, height also increases. So if you were to describe the relationship, and I heard, so this data, this relationship is positive, and how do we know? Even just by looking at the graph, if you were to draw your line of best fit, would you draw a line that rises to the right or a line that falls to the right? Rises, which means it's positive. So what I want you to do right now is I want you to take a ruler and you're going to draw a line of best fit. What is a line of best fit? So you're drawing a line that is as close to all the points as possible. It should pass through as many points as possible, okay? So in this case, look here, please. This is very important. Everyone, eyes over here. I would not start at 0, 0. If I draw a line like this, that's not even close to my points, right? That does not represent the data. So we're going to start, we want to draw a line as close to all the points as possible, so I'll probably start here and draw it like that using a ruler. If you don't use a ruler, it's incorrect. You have to use a ruler. And you're putting about half the points above and below the line. So you want to kind of center the line. That's a line of best fit. Okay, this is my line of best fit. And the reason we use that line is why? Why do we use a line? Because your line shows the trend, which means you can use it to predict things about the future. I can extend the line and I can say to you, well, according to this trend, when Julie is 10, remember we did this? Everyone tell me, when she's 10, approximately how tall would she be if she keeps up with this pattern? If she continues to grow, what would be a good prediction for when she's 10 years old? How tall do you think she might be at that age, according to this pattern, according to this trend? According to the trend, she'd be around 160 centimeters. That's an excellent prediction. I wouldn't say, oh, she'd be around 200.
No, it should be 170.
Between 160 and 170, it's dependent on how you draw your line. We'll get different answers, okay? Your line of best fit has to be a straight line, right? So you have to use a ruler. It shows the trend in the scatter plot, so you have to make sure it's close to the points. And it should pass through as many points as possible, with about half the points above and half of the points below the line. Okay? So the line must follow the what? Trend. Excellent. Oops. Trend. The line should blank through as many points as possible. It should go past, that's fine. Pass through as many points as possible. And there should be a blank of points above and below the line. There should be an equal number, or we can say half of the points above and below the line. You don't need to sit there and count, but you should estimate using your eye roughly the same number of points above and below the line. Okay, and then the last point, the line should pass through points all along the line, not just at the end. And some of you didn't do this. I came around. You have to extend it all the way to the other side, basically. Okay, so let's make predictions now. We're going to use the line of best fit to estimate the following. What's the first question? When she was 5 years old, how tall was she, roughly? 109 centimeters. Shh. How tall will Julie be when she's 9? So you actually had to extend the line to predict that one, right, Jay? 150. That's a good prediction. Okay. How old was she when she was 100 centimeters? Roughly how old would you? 4 years old. Good. 4 years old. And when she was born, which means she was 0 years old, how tall was she? 60, not 70. 70 is too high. 60. When she's born, 0. There's something called interpolate or extrapolate. So when you interpolate, listen carefully, you are making the prediction within the data, meaning that data is there. Look here. All these points were here, so we can get the data from within the graph. When you extrapolate, you are making a prediction outside the data, which means we had to extend our line. We had to draw a line and we had to extrapolate. It's like you're taking it out of the information. You're making a prediction, okay? So it often requires you to extend the line. So these predictions are less reliable because you don't actually have the data there. You're predicting based on the trend.
So we can't get it wrong.
No.
Unless it's like
Unless it's way off.
Yeah.
When you interpolate, the predictions are usually there, let's say. They're on the graph. Okay? So you're going to go back and you're going to tell me your method of prediction for each one. Did you interpolate or did you extrapolate? You can write I for interpolate or E for extrapolate. So to figure out how tall Julie was when she was 5, was that data within the graph or did you have to extend it to get that information? When she was 5 years old, was that graphed? It was within. So we're going to say we had to interpolate. To predict how old she was when she was 9, was that within the graph or did you have to extend it? Extrapolate. E. Think of the letter E. You had to extend it. You're extrapolating. Okay? How old was Julie when she was 100 centimeters? Did you have to interpolate or extrapolate? Was that on the graph already? Yes, it was. And then to say how tall she was when she was born, did you have to extend your line for that? Yes. Excellent.